In this video I want to show you a so-called test transmitter. What is a test transmitter? Well, a test transmitter is a unit that covers a wide frequency range and also offers different modulation modes. This test transmitter has an off. This test transmitter has an on-off switch, wherewith you can switch it on or off, a control LED that tells you that the transmitter is turned on, a modulation input, a standard connector, headphone jack. Here is an attenuator. You can turn it on and it will weaken the signal output, or you can turn it off and it won't weaken the signal output. BNC output connector. Here you can switch between AM and FM, so you can broadcast either in FM or AM, depending on FM or AM, what mode do you need. FM you could use for a CB radio, at least in Europe, and AM you could use for a radio. Or you could also use FM for amateur radio if you have amateur radio license. Anyway, here is a switch that selects the band, and as you can see, I have activated the first switch. I have activated the last two switches, and if you have a look at the color, you can see I'm in the high frequency range. I'm in 27 megahertz, and I'm currently broadcasting on 27.120 megahertz in AM. And I would like to broadcast via an antenna. I like to connect an antenna and broadcast wirelessly into this receiver instead of wrapping the RF output wire around. But I made it too good. The output from this transmitter is so weak. I get a range of like 2 inch, and this is not good. I mean, this is exactly what you want to have on a test transmitter, but not if I want to make it on a video, because over this distance, no signal reception. Just if I couple it via a coupling wire, then it will be receivable. So this is a very, very weak transmitter, but it's intended to be weak because you usually connect the output from the ENG connector, you connect it directly to the input from the receiver, and therefore also have the attenuator switch to even weaken the signal more. So if you build a radio, you can align it using this transmitter. And also you can have an IF signal. You can have an IF signal with this transmitter here, and then you can align the IF stage. Anyway, I'll turn on the receiver. And this is AM.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
This is an endless loop, obviously.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
And now I switch over to FM.
120 Meter wieder weg vom Haus.
And there is a trick receiving FM with an AM radio called slope detection. If I turn it next to the frequency, you can hear it, but if I turn it exactly on the frequency, then it's very silent. If I now switch over to FM, and switch back to AM here, so as you can see, the transmitter features FM and AM, and it also features a wide frequency range. In this video I will show you how you can build this transmitter step by step and what steps are required, creating your own signal generator or test transmitter, however you want to call it. Now I want to have a look at the test transmitter and I want to see what's inside. So I open up the screws and I can take off the cover and have a look inside. So let's open the other screw, and then I can take off the cover and we can have a look inside. So this is how the test transmitter looks inside. There's a 9-volt battery, a little bit of electronics, and that's pretty much all there is inside for making your own small. This is how the test transmitter looks inside after taking off the cover. As you can see, there's not much inside. And this is why I recommend. As you can see, there is not much inside. And this is why I recommend you to build a small and tiny test transmitter. Here you can see the circuit boards after I used the Dremel tool and worked on them. Here comes the switch for selecting the frequency and some other components. So this is the front from the transmitter, this is the back. This is the top side or the cover with some holes for the screws. They aren't yet big enough, but I will make them big enough then. So I will make them big enough if I know where I have to place the nut. This is the ground. This is the needle that shows you the frequency. It will be soldered to the tuning capacitor. Here are the 5x5 millimeter parts where you can solder in the parts later. This is a circuit board for the dip switch. It has been made from the leftover or from the remains from the 5x10 centimeter plate. It has been made from the remains from the 5x10 centimeter. It has been made by the remains from the 10x10 centimeter plate. It has been made by the remains from the 10x10 centimeter circuit board and will hold the dip switch. And here are 3x1 centimeter parts which also will be needed in the circuit. Okay, these are all circuit boards from the transmitter. Here I have the parts prepared for soldering in. I've cut the wires and I pre-tinned the wires. This one up here is the 5 volts voltage regulator and this one is the S. Here you can see the parts prepared for soldering in. Here you can see the parts prepared for being soldered in. Now you can see the parts ready to be soldered in. This one is the S9018 transistor. Meanwhile on the right side it's the 5 volts regulator and both in the middle are BC548 transistors. I've cut the wires and pre-tinned them so the parts can be soldered in quite easy. Okay, so the next step that I'm going to do is I'm going to glue the frequency selector and some of these smaller ones. I'm going to glue them on top of the ground circuit board and you will see a detailed photograph, as you will see a detailed photograph of the parts, which one belongs to where. And then we can proceed building our small AM/FM test transmitter. And then we can proceed building our small test transmitter. Here you can see the circuit boards. They have been cut. This is 1.2 centimeters, 1.8 centimeter and 6 centimeter. This is 3 centimeter times 7 centimeters, and this is the same. Okay, these are the circuit boards after they have been reworked and cut. This is the circuit board with the resistors all installed. You can see that I've also added some wires, and here is one wire going to the 1K resistor. This is the wire that goes to the LED plus, so that the LED is supplied, the power on LED. This wire over here. What you can see here is the circuit board with all resistors installed. Additionally to the resistors, I've also installed some wire. Here you can see the 1K resistor, which is the one for the plus lead for the LED, the power on LED. Here you can see some RG174. I've installed it like that the middle connection is going to collector from the transistor and the outer connection, which is shield, is going to ground. On the other side of the wire, I've only used the inner connection and I cut away the shielding, so this one's going to the tuning capacitor, wherewith we align our test frequency or transmit frequency. Additionally, I've installed a wire from here, from plus, to there, which is the other part from plus, so on these switches. And also I've installed a wire here with a 100K resistor in series. This one goes to the middle of the tuning potentiometer or frequency fine-tune potentiometer. Now we are already done with all the steps that are required for building the transmitter. It's time to do some other stuff. So now you can see the back from the front. Well, that sounds odd, but this is the front panel, and I've installed the switches and potentiometer and stuff like that. I've installed it, but I have not added the paper on the other side because when I was doing another project and I added the paper before I soldered in the wires, after working on this device, the paper got dirty and that's not what I want. So I now have installed the parts, and what we are going to do now, we are going to take the wire and we install, for example, one wire here, and then we look how much wire do we need to get from here to the circuit board. And then we install the wire on these components, or not on this one, but on these components we install the wire, add some shrinking tube, and then we take out the components again. Then we install the paper, and then we only need to screw in the components back in, and the circuit should be good to go. So then it won't be that dirty, and we can work with it. Okay, that's the next step. So now I've soldered both parts together, the main circuit board and the front, as you can see here. And what we're now going to do is, once again, I'm, for example, taking a wire from here, I'm soldering it in here, and I know this one needs to go to plus, so I have to look how much wire do I need to get from plus to here, and then I cut the wire, add some shrinking tube here, and do the next parts, until all parts are wired. But I won't connect them constantly to the circuit board, I'll just look how much wire do I need, because once again we will need to take out these parts again. So this is the next step in the test transmitter circuitry. So here you can see the circuit board, and I've added lots of wires. As you can see, I've also added shrinking tube here on the switch. This is the AM/FM switch. And one lead, for example, would go here, which would be FM. And the other lead would be going down here on this other capacitor, where the potentiometer is. This one here, and this would be AM. And I haven't soldered them to the circuit board, because what I'm now going to do is I'm going to take out all components again. I'm going to take out the potentiometer and switch and all the stuff. I'm going to take it out, and then I'm going to glue the paper on front, make holes into the paper, and then I'm going to put back the parts. I'm going to put them back in, and then I'm going to solder the leads where they belong to. Okay, also, this is a project I've been working on for quite some time. I made breaks between each step, and you can see that the copper, by touching it, it kind of got bad, so you can't really solder that good on that copper. It won't take on solder any good. So what I did is, as you can see here or here, I've scratched away this dirt, if you want to call it like that. So I scratched away the dirt, and now I can solder in the components. Also, I don't solder a wire here, because this lead must go to minus. I don't solder a wire from here to minus, I just bend the wire and solder it directly to minus. Okay, so this is how parts are installed. The next step that I'm going to do is I'm going to go ahead and take away the... now I'm going to take out the parts again. I'm going to take out the switch and the potentiometer and everything else, and then I'm going to glue the paper on front of this circuit board. Also, I'm going to solder the circuit board away from the other circuit board, and then I'll be ready to build in the parts again and solder them to the circuit board. Okay. So here you can see what I've done with the housing. I've added this dial here where we can later tune on the frequency. It's not perfectly fitting, but if I go on lower frequencies, it will press itself against the housing. So it has to be really careful with this tuning capacitor. So you must be really careful. When soldering this one in, the tuning capacitor is set When soldering this one in, the tuning capacitor is set to minimum frequency, I mean minimum capacitance, which means highest frequency, and here's highest frequency, meanwhile here's lowest frequency. So, if you solder it in, solder very short, because otherwise the tuning capacitor will get too hot, the foils inside will melt, and that will destroy the tuning capacitor because it makes a short circuit. On the back, as you can see, I've installed all wires. Well, you could add some tape and lay them in here really fancy if you want to call it like that. But for me, for a testing purpose or for this project, it's okay so far. And you can see that I've soldered in the wires here. So as I said before, the switch goes here, which means you can modulate it FM or AM. And I've soldered in pretty much everything. All that needs to be done now, the transmitter already is working technically, so I tested it and it's working. All you need to be doing now is to mount the nuts here for the screws that you can mount on the cover, and add the side walls, add one side wall here and add this wall here, and then this transmitter is ready for operation, well, at least for alignment. I've tested to put in the battery, and these things here are really much taking space, but the battery still fits in. It can be put in and it works. Okay, so in the next part I'm going to install these nuts here on one side and on the other side, so I can mount the housing, I mean the top, and also I'll install this wall on the back here, so this transmitter is going to be more and more complete. So here you can see the test transmitter built, and I've added the nuts so I can mount the cover on this test transmitter. And I've pretty much soldered everything together. The transmitter is working. All that now needs to be done is I have to write audio input, RF output, and so far and so on. I have to write that stuff on top or on the front from this device, and then here I will have to write which frequency is in which position, because you can make many frequencies with this test generator, and I will have to figure out which position and which switch is going to belong to where, so that we can get a certain frequency. Okay, the next thing that also needs to be done, or something that also needs to be done with this transmitter, is align this potentiometer. You can see the potentiometer here pretty much in the middle of the picture, and when you get this transmitter, or when you build this transmitter, you have to align the potentiometer in a way that the potentiometer is turned to the left side. Not completely, but it must mainly be turned on the left side, not completely but mainly, because if you don't do this, you won't have any RF output, or you will only have a very, very weak RF output, and this transmitter already is very weak and this transmitter, if you don't align the potentiometer correctly, when the potentiometer isn't aligned correctly, you won't have any RF output. And the RF output is already very low on this transmitter, because it's just a testing transmitter which is supposed to be weak, because it doesn't make sense if you have like a 2 or 3 milliwatt strong transmitter and feed that one into your radio, the radio will receive it everywhere if you connect it directly. So this one's already very weak, and also, as you know, it has the attenuator function to even weaken the signal more. But well, okay, in the next step I will show you how I align this transmitter. Here's the test transmitter. Now we've written letters on it, so modulation input, RF output or HF output, and so far and so far, and so on. Anyway, what I'm now going to do is I'm going to test, or better, I'm going to align, I'm going to write the frequencies in a rainbow-like scale, so that we know which frequency has been tuned in. Here's my receiver, and I have, for example, now turned on the first 2 switches. And I know when I was developing this, that is the IF frequency range. So you want to have a 455 kHz transmitter for aligning a radio. And here I have, for example, 470 kHz. And now if I turn on the test transmitter, it does generate a signal. And now, if I'm going to move this, I can untune it. So if I move it back, you can see that the frequency is 470 kHz again. And what I'm now going to do is I'm going to look which frequency here is the maximum frequency, and then I'm going to write it down, and which frequency is the lowest frequency. The frequency fine-tune potentiometer therefore is in the middle position, because you want to have some space left that you can align the frequency a little bit. Okay, so this is the alignment of the frequency rainbow scale. So now I'm going to align the transmitter. As you can see, I've now written letters on the transmitter telling you different information about what does what. And how I'm going to align it, unfortunately I don't have a connector from this SMA connection to the BNC connector, so I took some coax cable and soldered it to the BNC connection, and I'm going to demonstrate you how I'm going to do this. Therefore I have set the first frequency steps 1 and 2, means that I'm going into the IF range, because of course you want to have a test transmitter for the 455 kHz IF frequency of most radios. And so I'm going to turn on the radio, or better the receiver, and you can see that there is no signal, but as soon as I turn on the transmitter, I'm having a signal. Listen when I turn on the attenuator. There's much more static now. I'll turn it off. You can see that the attenuator is working as well. You can see that the attenuator is also working and reducing the signal strength. This is good if you want to align a radio for most sensitivity. Anyway, when I'm going to move the frequency scale, or better the frequency dial, you can see that I'm untuning it. So I can tune and untune the transmitter by moving the frequency scale, or better the frequency dial. And what I now need to do is I want to have it on maximum frequency, check what's the maximum frequency, write it down, then I go to the lowest frequency, and so I start writing my numbers and scale on this paper. The frequency fine-tuning potentiometer therefore is in the middle position, because you don't want to have it on maximum or minimum, because you want to have some tolerance where you can move it, so you can tune in eventually. If the temperature changes, the frequency will drift a little bit. You can tune in the frequency so it matches the scale again. This is going to be the alignment of this transmitter. So this is the alignment of the bias for the AM modulator. Of course, the test transmitter has to be switched to AM, and I've tuned in a frequency. I've activated these two switches, and I've tuned in a frequency. I've activated these two switches, which means I'm on 2.33 megahertz, just a random frequency, and here you can see the frequency, and you can't hear anything because it's not perfectly aligned. I've connected my MP3 player to the input from the transmitter. Here's the MP3 player connected, and now I'm going to turn on the potentiometer which you saw before. I'm just going to turn it until I can hear the modulation.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
This is a loop transmission.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
So this is all that you need to do. I switched to FM so that you won't hear anything from this modulation because it's always the same. So this is all you need to do. Just align the potentiometer on any frequency and you will be able to hear a good transmission signal. In this clip I want to show you how to align the modulator stage from the transmitter. It's only relating to the AM modulator circuit from the transmitter. Here I have connected my MP3 player to the audio input, and there is already a loop file playing something that I say. Anyway, I've chosen the frequency 2.33 MHz. By selecting on the dial, I select the right frequency, then I have a look which one is the frequency and tune it in. Okay, of course for aligning the AM modulator you have to switch it over to AM, and I can already hear it, but it's very distorted. And all I'm going to do now to align it, I'm going to turn on the potentiometer and it should work.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
So this is an endless loop.
So, jetzt sind wir 120 Meter wieder weg vom Haus.
If I switch over to FM,
So, jetzt sind wir.
you can't hear it because if you turn it on exactly the same frequency, which is the transmission frequency, you can't hear FM with an AM radio or AM receiver. And so this was all that needs to be done for aligning the AM modulator. If you change the frequency, there's nothing you need to do. It will keep working. Okay, that was the alignment of the AM modulator.